guys, now it's time to discuss neuroplasticity. Again, it's time to discuss neuroplasticity definition. Ability of neurons to change function, chemical profiles or structure. A nature innate process within the nervous system underlying learning and adaptation. An essential function of nervous system to recover from damage occurs throughout the lifespan. Not inherently good, can be adaptive or maladaptive. In neuroplasticity explains how the human brain is able to adapt, master new skills, store memories and information, and even recover after a traumatic brain injury. It's the change that happen in the brain that result in changes in function in response to new information, sensory stimulation, development, damage or dysfunction. Memory, movement, reaction, time, skill improvement, skill reduction. The idea of neuroplasticity was first proposed by William James in 1890. Organic matter, especially nervous tissue, seems endowed with a very extraordinary degree of plasticity. Then when neuroplasticity occurred, period of heightened plasticity during the ontogenic critical period, limited time during which the nervous system display heightened sensitivity to environmental stimuli, and the maximal during the first 2 years of the life. After the critical period, the brain may never again show the same ability to make big changes in neuronal connectivity. What is denervation supersensitivity? This phenomena occurs when cortical neurons are lost. Due to damaged neurons, there are no nerve signals passing across these neurons. Thus, to compensate this, the postsynaptic keep it remember, when there is no signals passing, then obviously the neuron will fire the postsynaptic membrane so the nerve signal may pass. There may be more receptor at postsynaptic membrane for the transfer of the nerve signal. The phenomena of increased receptor at postsynaptic membrane lead to supersensitivity in the denervation stage. This picture is telling us giving us a good example in which there is hindrance in presynaptic membrane and the signal is not passing, then their receptor increased as postsynaptic membrane, so we can say that there is the hypersensitivity. And then long-term potentiation. Actually, long-term potentiation is excitation. When the glutamate binds to receptor present over the membrane, this leads to stimulation of AMPA and that allow influx of sodium. What actually happens? Influx of sodium inside and magnesium ion are released. Influx of sodium inside, and for the outside magnesium ions are released, which block NMDA. When NMDA block and AMPA is releasing, then obviously there is magnesium ion released and sodium influx inside, and this will lead to excitation, and all this lead to activation of protein kinase C colmodulin kinase. This is long-term potentiation. This is a picture of form. This picture is telling you the whole process happening. Okay, in long-term depression there is reverse. In long-term depression there is inhibition. LTD induction requires low frequency stimulation 1 Hz over a prolonged time period 5 to 15 minutes in cerebellum. Next there is again synaptic strengthening. When there will be more fibers, then more strength of neuronal signal. Cells that fire together wire together. Structural plasticity. Plasticity at the synapse take the form of alteration in amount of transmitter, in number, and alteration in membrane excitability. In taken together, these plastic changes will increase or decrease the efficacy of some synapse, increase or decrease the number of synapses.